Hello everyone. Today we are here to talk about some basic semiconductor devices. Let's start our topic with conductor. Okay, without wasting the time. So we are starting our video with conductor. Okay, what is conductor? The first question is arise in your mind is that what is conductor? So the basic definition of conductor is the material. Conductor is the material which allow current through flow it easily. Okay, so in the conductor, current can flow very easily. Up to here clear? Very good. Next is, let us know some example of conductor. Examples of conductor. Some example of conductor are silver. The atomic symbol of silver is Ag. Next is our gold, Au, copper, aluminium, mercury, and seawater. Yeah, seawater. These are the elements which allow the current to flow it easily. That's why they are called conductors. Okay. Now let's talk about some basic properties of conductor. Okay. Some basic properties of conductor. It will start with that conductors have high conductance. High conductance. Okay, conductance. Now because it's have high conductance, and we know that conductance inversely proportional to resistance. So because of high conductance, its resistance will be low resistance. Clear? The resistance of the conductors are very low. Okay, now next property of conductor is it's allow the movement of electron and any ion in it. Okay, in conductor, electrons and ions can move easily, can flow easily, but within the conductor. Clear? Next, the electric field. I denote the electric field with E. Okay, the electric field of conductor is 0. Clear? That's why the electrons flow within them. The electrons flow within them, within a conductor. Okay, up to here clear? Very good. Next point, the charge density, that is rho c of a conductor is 0. Okay, I am denoting the density with rho, and because it's a charge density, so I write rho c. The rho c of a conductor is 0. Clear? Last property of the conductor, that is the potential of conductor in each point. Potential of conductor in each point is same. Means its flow with equal potential. Okay, I denote potential with V here. Clear? Up to here. Now let's talk about conductor band diagram. Okay, so this is energy band diagram of conductors. So here we can see this is valence band, this is valence band, and this is conductance band, and they are overlap in this area. They are overlap in this area. Because of that, conductors transfer electricity. Conductors transfer electricity very easily because of valence band and conductance bands overlap in the area, in a particular area. Conductors pass electricity very easily. Okay, transfer electricity very easily. Up to here clear? Let's talk about some basic concept of insulator. What is insulator? Let's first write what is insulator here. As we know, we already studied that a conductor is a material from where electricity or current can flow easily. But insulators are the device that don't allow electrons to flow them easily. Means electricity can't flow from the insulator very easily. Okay, from insulator current or electricity, or you can say electrons, not flow through them, clear? Not flow through them. Some examples of insulators are rubber. The basic and the most important example is rubber. Rubber is an example of insulator which don't allow the current through flow to it. Next is polythene. We have paper also, which is an example of insulator, and many more. Okay, some properties of insulators are: because from insulator current can't flow, so its conductance is very low, means conductance low conductance. Clear? As we already discussed earlier that conductance is inversely proportional to resistance. So because of low conductance, resistance is high. Clear? Resistance is high and its range will be 108 to 1015 ohm. Clear? Now insulator does not allow, second property, that is insulator does not allow electrons to flow through them. Electrons cannot flow through it. Clear? Next is its have large dielectric strength. Clear? I think you already understand all the properties. So insulator, the properties of insulator. Let's start with the properties of insulator. First properties is insulators have very high resistance. Its resistance will be very high because current can't flow through it, so its conductance are low. And as we already discussed that conductance are inversely proportional to resistance, and because conductance are low, its resistance will be high. Its range is 1008 ohm to 1015 ohm. Clear? Very good. Next talk about insulators, some other properties of insulator. Next property of insulator is insulator does not allow any electrons to flow through it. Does not allow any electron to flow through it. Means in a insulator substance, electron cannot flow. Clear? Next property of a insulator is it's have large dielectric strength. Its dielectric strength is very high. Okay, its dielectric strength is very high. These are some basic properties of insulator. Now let's talk about insulator energy band diagram. So this is the energy band diagram of insulator. As in the earlier stage when we are discussing about conductor, we can see that valence band and conductor band are overlapped in a space. Because of that, in conductors can flow electricity very easily. But here in the insulator, we can see that in between conductor band and valence band, we have a space, we have a vacant space. And what is that vacant space filled with? 15 electron volt. Because of this vacant space, forbidden energy band, this band is called forbidden energy band. Because of this forbidden energy band, we said that in insulator, current cannot flow, electron cannot flow through it. And because electron cannot flow through it, electrons cannot flow through it, current also can't flow. Clear? This is the energy band diagram of an insulator. In conductance, we can see the conductor bands and valence band are overlap each other, but in insulator we can see in between conductor band and valence band we have a forbidden energy band. Means we have a space between them, and this is a space between 15 electron volt, and because of that electron can't flow in it. Clear? Let's talk about semiconductor now. Let's talk about semiconductor. First of all, what is semiconductors? Semiconductors are the material which exhibit electrical conductivity lies between conductor and insulator. Means its conductance are greater than insulator. Conductance are greater than insulator, but less than conductor. It lies between these two, conductor. It lies between this insulator and a conductor. Okay, clear? Some example of semiconductor are silicon is a basic example of semiconductor. Next is germanium. We have many more examples, but these are the two common. Okay, now let us talk about the basic properties of semiconductor. Clear? As we already know, it's in between conductor and insulator. It's in between conductor and insulator. Here I denote SC as semiconductor. Okay, because we have a very less space for that. So semiconductors have resistivity is less than insulator, but greater than conductor. What about conductors? Conductance will be greater than will be less than conductors but greater than insulator. Clear? This is the basic property of in semiconductor. What is this? That the conductance is the conductance and resistance both in between conductor and insulator. Clear? Insulator. Next property is at 0 Kelvin temperature. At 0 Kelvin temperature, our insulator, sorry, I'm very extremely sorry, our semiconductor act like a insulator. Means when we have a temperature of 0 Kelvin, that time semiconductor act like an insulator. Clear? And when the temperature started increasing, that time semiconductor, again I am denoting semiconductor by SC, semiconductor act like a conductor. Clear? Very good. Next is the conductivity of semiconductor. The conductivity of semiconductor increase when we add impurities. Where I denote add by plus, when we add impurities in it. Okay, this process of adding impurities is called doping. Well, we discuss doping after few minutes. We discuss all the things about doping after few minutes, but first understand that when we add some impurities in a conductor, that in a semiconductor, that time our semiconductor increase its conductivity. Okay, and because it's increased conductivity, its resistivity started decreasing. Already know that conductivity is inversely proportional to resistivity. Clear? Next, talk about the energy band diagram of semiconductor. So this is the energy band diagram of semiconductor. In conductor, we can see in the conductance bands and valence band that they are overlap each other. In insulator, we can see there is a gap of 15 electron volt, but in the semiconductor we can see the gap between conductance band and valence band is just 1 electron volt. Because of that it's in between conductor and insulator. Means it's act like a conductor or might be insulator in simultaneous time. I think up to here you have clear about these three topics, that is conductor, insulator and semiconductor. Okay, very good. Next, let's talk about, we have some other topics of semiconductor, that is intrinsic properties, extrinsic properties of semiconductor. What is intrinsic semiconductor and what is extrinsic semiconductor? Okay, let's start with intrinsic semiconductor. What is this? Intrinsic semiconductor. So what is this intrinsic semiconductor? Let me write first. So the first definition of intrinsic semiconductor is a conductor that exceeding purely means so intrinsic semiconductors are those conductors which don't have any impurities. Means these semiconductors are free of impurities. Means they don't have any impurities. Example of, sorry, it's very bigger. It's look like a impurity, I know. The examples of intrinsic semiconductors are silicon and germanium. Okay. Now in this intrinsic semiconductors, the flow of electron will be random. Means as they grow from the valence to the conductance valence, means from valence to they go conduction bands. Okay, electrons flow in this way in this intrinsic semiconductors. As a result, the TCR of this semiconductor will be negative. Now what is this TCR? Sorry, let me write this. What is this TCR? This is temperature coefficient resistance. The temperature coefficient resistance of intrinsic semiconductors are negative. Okay, negative, because they are act like a insulator. Very much clear. Let us talk about extrinsic semiconductor. What? Extrinsic semiconductor. Extrinsic semiconductors are those conductors which have impurities. Means this contain impurities in it. Okay, means impurities are introduced in them. Clear? The extrinsic semiconductor will be divided into two parts. Okay, will be divided into two parts. One is N type, another is P type. Clear? One is N type, another is P type. So what is N type semiconductor? N-type semiconductors are those conductors which have impurity mix in it. As we already know that it's a extrinsic semiconductor, it's a part of extrinsic semiconductor. That means it's have impurities in it. But from where these impurities are coming? These impurities are coming by mixing the pentavalent impure atoms. Okay, but what are that pentavalent impure atoms? They are phosphorus. Next is arsenic, antimony, next is bismuth, and many more are there, which is added to N-type semiconductors, which is added to semiconductor as impurities, and because of that N-type semiconductors are there. Okay, they are used as a chemical elements which are used to produce N-type semiconductor because of these elements. If these are not there, then no N-type semiconductors are there. Clear? Very good. Most of all, group 4 elements have come as a most of our group 4 elements are coming here to be impurities, to act like a impurities to make a N-type semiconductor. Clear? Next is P-type semiconductor. What is P-type semiconductor? Let's discuss this. P-type semiconductor. P-type semiconductor. Semiconductors like germanium or silicon doped with any one of the trivalent atom like boron, indium, it's not India, it's indium, or gallium are called p-type semiconductor, Clear? Let me tell you one more time that when semiconductors like germanium or silicon dot with any of the trivalent atom like boron, indium or gallium, then we can say that these types of semiconductors are known as p-type semiconductor. Clear? The impurity atom is surrounded by 4 silicon atom. The impurity atom is surrounded by 4 silicon atom. These are the impurities atom, we can say, and it's surrounded by 4 silicon atom. Okay, it provides the atom to feel only 3 covalent bond, as it has only 3 valence shell. These impurities have only 3 valence shell. Because of that, it's able to make 3 covalent bond with the 3 silicon, not with all the 4. Okay, this is the basic definition of p-type semiconductor. Hope it's clear to you. Let's start the last topic of today's class, that is idea of doping. What idea of doping? What is idea of doping? Let's understand it as we learn it, as we read it little bit of a few minutes ago. Let's read. So, idea of doping. Doping is a very easy concept. What is doping? Doping means when we add impurities in a semiconductor, then we can say that is called doping. Okay, during the production of extrinsic semiconductor, I denote extrinsic semiconductor by ESC. Okay, during the production of extrinsic semiconductor, the amount of kind of impurities to introduce in the material must be carefully monitored. Means we have to carefully monitor that how much amount of impurities we are added into the intrinsic semiconductor, because in most of the cases one impurity atom is introduced to every 100 semiconductor atom. Means one impurity atom equals to 108 semiconductor atom. Means 1 impurities atom is introduced to 108 semiconductor atoms. Clear? If you understand, let's talk about the last portion of our video, that is formula formula of formula of formula of doping concentration. Formula of doping concentration. What is the formula of doping concentration? It is EF. It is E, capital E, F equals to EFI EFI minus KT minus KT. Clear? This is the formula of doping concentration. I think you understand it. We have to take this formula and we have to find the doping concentration of any impure semiconductor. So this is the formula of doping concentration, for finding out the doping concentration. Now we are very near to finish our video. Hope you all understand the topics. We try very much hard to make you understand the topic. If any part you feel that you can't understand it, then don't hesitate to ask us. You can write in the chat box also. We try to answer that. Now for today's, we are ending our video here. Thank you for watching it. Hope your day will be wonderful. Tata. Thank you.